Lesson number 5. Lesson number 5 is about one specific type of triangle, and it's called a 45-45-90. And it says some right triangles have special properties, and there's actually 2 of them. But what we're going to look at today is just one, so we're only going to focus on one of the 2. So in lesson 6, you'll focus on the other one. So this particular lesson is all about what happens when you first start with a square. So let's follow the kind of instructions along the side here. It says ABCD is a square and draw on a diagonal. So if we just connect the corners here, the vertices, that would be a diagonal. Now it said, what did drawing in the diagonal do or create? And basically what I'm noticing here is I've got 2 equal triangles. Now it says find all the other angles. Okay, well, if this is 90, then that means this is going to be 90. So really I just have to focus on one because these are going to be carbon copies of each other. So if this is 10 and it's a square, then that's 10. And if this is 90 and this was 90, then that makes this a 45, and then that makes this a 45. Now, using Pythagorean, so basically from the previous lesson, 5-4, I can use Pythagorean theorem and go a squared plus b squared, and that will give me this one. So if I do 10 squared plus 10 squared, that will give me c squared. So that's 100 plus 100, so that's really 200 is equal to c squared. If I take the square root, and if you break this down, the square root of 200 is really 10 square roots of 2. Okay, so now I'm going to fill that in here, 10 square roots of 2. Well, there's kind of a relationship that gets created with these numbers. Let me show you another example just so you can kind of see the relationship, okay? So you don't have to write this down or anything, but I'm just going to draw another square. And if we were in class, I would tell you to give me a side length, and I'd tell you to kind of keep it kind of small or something. But let's say you pick 8. So if this is 8, that means this would be 8, and we would draw in the diagonal. We know this would be a 45 again, and this would be a 45. And then again, if I do a squared, b squared, c squared, so, sorry, I bumped the paper here. I'd have 8 squared plus 8 squared is equal to c squared. That's 64 and 64. That's 128 is equal to c squared. And if I take the square root of both, I don't know how you want to look at it, how you break it down. If you do the tree, or if you do, the multiple method. I like the multiple method, which if I were to do the multiple method, that would be really, if you look right there, it'd be 64 times 2. That's 128. So the square root of 64 is 8 square roots of 2. So 8 square roots of 2. You noticing any pattern? If not, I'll do one more. Take another square, and again, if we were in class, I'd say, tell me, a side. So let's say we do this corner, and we'll draw the diagonal in this way, and then you'd give me a side length. So let's say you tell me it's 11. I'm just using small numbers here. If that's 11, that's 11, and this is a 45 and a 45 because it got split. So then I'd have 11 squared, and c squared. That's 121 plus 121, which is 242. And again, take the square root. But I like the multiple method again, so I would think of this as 121 times 2, because there's 2 of them, so 121 times 2, which is 11 square roots of 2. So this is 11 square roots of 2. Are you noticing kind of a little bit of a pattern? Like 11, 11, 11 square roots of 2. 8, 8, 8 square roots of 2. Remember, back on this side, 10, 10, 10 square roots of 2. Now if we were in class, I'm hoping somebody would yell it out or tell me or whatever, but basically what we're noticing is obviously the sides are the same, and then whatever number this is, that would be that number square roots of 2. So the relationship here, like if you want to draw yourself, like a little square, is that by drawing in the diagonal, you split it, and these become 45 and 45. And whatever the side is, let's say you call this x, this would also be x. Then this would be x square roots of 2. Okay, so that's kind of the relationship that exists. Now, really that's the whole property for this lesson. So what you do is when you look at these pictures, you know this is a 45, which means this is also a 45. If this is 8, you know this is 8. And then this would have to be 8 square roots of 2. Now, if you don't like doing that, you could work out Pythagorean. 8 squared, and then c squared, which, I mean, I actually already did that one because I used the number 8 on the previous one. So you can use Pythagorean theorem, but I will tell you that if you can learn this rule, it'll go much faster. Notice on this one, see how the 2's are the same? So that means this is just going to be 2 square roots of 2. On the next one, see how you have a 17? That means this side is 17. And I know they're not asking you for it, but it's still good to do. And that means this would be 17 square roots of 2. Now again, if you don't like that, do Pythagorean. 17 squared plus 17 squared equals c squared. When you turn to the next page, notice it gets a little bit more tricky because now they're giving you the hypotenuse. See, before it was whatever that was, like, 2 square roots of 2. But now this is x square roots of 2. So you have to solve this problem. So you're going to have to go 5 is equal to x square roots of 2, and you're going to have to solve this thing for x. So this will cancel, but now you have to do what we call rationalizing the denominator. So you have 5 square roots of 2, so then you have to multiply by the square root of 2 over the square root of 2. So that's 5 square roots of 2 over the square root of 4, which is really 5 square roots of 2 over 2. And then this would be your answer that belongs up here. So it's a little bit harder when they give you the hypotenuse than when they give you the legs, okay? So I'll do number 5 with you, and then I'll let you try the last 3. So number 5, it's 16, so it's going to be almost identical. If you notice, those are basically the same picture, just different number there. So this is x square roots of 2. So you're going to have to divide off the square root of 2. This will cancel, and you have to rationalize the denominator. So that's 16 square roots of 2 times the square root of 2 over the square root of 2. That's 16 square roots of 2 over the square root of 4, which is really the 2 on the bottom. But what is 16 divided by 2? 8. So this is really 8 square roots of 2. Now I didn't do that on the last one because what's 5 divided by 2? 3.5, or not 3.5, 2.5. So we don't want to have decimals. But this one came out to be nice, so that's why I went ahead and divided it out. So why don't you go ahead and pause it here and try the next 3 and see if you can come up with the right answer. All right, hopefully you've paused it and tried it, or you can, I guess, kind of watch each one and pause it in between. I'm going to write down the right answers, and then if you need help, I'll go through them. This would have been 4 square roots of 2. This would have been 25, and this would have been 20. So if you got those right, you're all done. You can move on to the homework. If you didn't get those right, let's go through them together. On number 6 here, the 8 is going to be your x square roots of 2, so you're going to have to solve this problem. So we're going to divide off the square root of 2, so those will cancel. So we have 8 over the square root of 2, and so we have to rationalize the denominator, so we're going to multiply by the square root of 2 over the square root of 2. That's going to be 8 square roots of 2 over the square root of 4. So that's really 8 square roots of 2 over 2, which 8 divided by 2 is 4. That's how I got the 4. The next one is actually probably a lot easier than you might have think. See, this is the same, and it's the same setup. They're giving you the hypotenuse, so you're going to let it equal x square roots of 2. Well, when you divide off the square root of 2, the one thing you should notice is they always cancel on the right, but normally on the left they didn't cancel. Where here now they will cancel. So you just have x is 25. That's how you got your answer. Now 8 was kind of a trick to make your mind switch back. Notice they're giving you the leg. So this leg is equal to this leg. Then you're going to take this number, whatever you have, and you're going to times it by the square root of 2. So that's really 10 square roots of 4. Well, the square root of 4 is 2. Well, 10 times 2 is 20. So that's how you came out with like a non-radical answer, because it kind of went away. So if you have any questions, please see me. But that ends lesson 5.5.